The previous page of the notes gave some ideas of sampling techniques that are good sampling techniques to use and has definitions of those. And this figure with tree sites is supposed to help illustrate those sampling techniques. The most common and a very good sampling technique is just selecting a simple random sample, which means that everything or person in the population is equally likely to be chosen, and that produces a sample that tends to be representative of the characteristics in the larger population. So if these are aerial views of trees, we're looking down from above, and each dot here represents a tree, a simple random sample will randomly select some of the trees where every tree is equally likely to be chosen. So I just have some little X's marked on different trees. The other two types of sampling are going to split our trees, or whatever you're looking at, your studied people or objects, into some subgroups and then sample from there. In stratified sampling, I have circled clusters of trees here, so we've got 6 of them. And what we do in stratified sampling is we sample within each group. So we have a sample of 4 trees here, a sample of 3 here, a sample of 3, a sample of 3, a sample of 2, and so on. So we sample from each group. In cluster sampling, we have the same breakdown of grouping the trees by location in this case. But what we do in cluster sampling is if I have these 6 clusters, I randomly choose which clusters to use, and I use everything in those clusters. So we got like cluster 3, cluster 4, and cluster 6, and we use everything from within those clusters. So here's a quick example of which sampling technique we'd be looking at. If researchers want to test a new math curriculum for 3rd graders, but they only have the budget to try it in 10 schools, that would be an example where we could use cluster sampling. Maybe we have 30 schools, but we can only use it in 10, so we randomly pick 10 of the schools, and we use everyone in those schools. And B, processor chips are continuously manufactured at a plant, and they want to sample the chips throughout the day. So the best way there is just to take a random sample throughout the day and get a sample of chips that way. We don't need to use a special sampling technique. And then in C, a player's agent wants to know the average salary for each position. Since we want some people from each position, we're going to break into groups by the position, and we would take a sample from each of those groups. At the very bottom then here, there's a couple of bad ways to get a sample, which may produce sampling bias, which means that what we get for the results of the sample does not really follow the population that we're interested in, so our numbers we would calculate would be off. One of those is voluntary response sampling. That is where we let people volunteer to be part of the study, and that was one of the things we saw in that motivating example in the past video where we were looking at the radio ad. And then another common type of sampling that produces biased results is convenient sample. That is where you use the most convenient group. That is really what that data set I'm looking at that I collect from my classes. That's a convenient sample. It's not a random sample of students. It is the sample of my students, and that is a convenient sample to use. If you've ever done some sort of study for class where you have to collect data and you just like maybe put something out there on social media and ask your friends to respond, that is really also considered a convenient sample.